Hello humans, Ryan Lemon here. We're going to be factoring this quadratic trinomial today and seeing how we can use it to help us solve polynomial functions and find their zeros. First, let's be aware of the process. The process. What you need to think if you're factoring something that looks indeed like this up here, you need to be thinking, what are two factors of C, whatever number's in this position, what are two factors of C that sum for B, this number? Be careful to include the sign as well. So if it's minus C, it's negative C. And here's the steps. Step 1, list all pairs of factors for C. Step 2, decide which two of these factors will sum for B. And then finally, write your binomials down, where you have the x in first position, and then you simply list one of the factors to create a binomial, and then you list the other factor next to the other x in the second binomial. Pretty simple process. Let's see it in action. Here we go. If the directions say to factor this quadratic trinomial, we can do that. We just got to remember our steps. The first step is to look at the idea of C, which is 36, negative, and list its factors. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. And 4 times 9, 36. Anything else? 5? No. 6. 6 times 6 is 36. 7, no. 8, no. 9 gets us back to this 9 right here. So I think that's it. Now, we've listed all the factors, and it's time to decide which of these factors has potential for creating a negative 9, which is B. Again, we're looking for two factors of C, so I listed all the pairs of factors, but two factors of C that can combine for a negative 9. 1 and 36 can either combine for 37 or 35. Here can combine for 20 or 16. Here can combine for 15 or, oh my goodness, 9. Sick. So here's our winning factors. Now we've got to decide what are the signs on these numbers to create a negative 9. Just so happens the 12 already looks like it. It's negative 12 with a positive 3. That can multiply back up to negative 36 and can add for a negative 9. And that's it. Now we just write our binomials with x in first position and each of the factors making the second term in each of the binomials. If you multiply these back together, you should get this result. In fact, let's check. X times x is x squared. X times negative 12 is negative 12x. 3 times x is 3x. And 3 times 12 negative is negative 36. Negative 9x is in the middle, negative 36 on the outside, and x squared in first position. Looks like it checks out. So our result of this being the same as this is absolutely true. Here's the factored form of this quadratic trinomial. Woohoo, it's so fun. We're going to step up our game a bit. We're looking at the function x squared minus 11x's plus 24. And we want to find the zeros of this function, or where the function crosses the x-axis. Now where the function crosses the x-axis, that's where y is 0, or the value of your function is 0. So we can make this statement to see if we can figure out a truth about x when our function is 0. Cool, we've got something equal to 0. Wouldn't it be awesome if we can write this something as a product? Because then it's easy to solve if we could write it like this. Good thing we just learned how to factor a quadratic trinomial. We take a look at the factors of C, which in this case is 24. The factors of 24, 1 with 24, 2 with 12. Notice I'm just going 1, 2, how about 3? 3 with 8. 4 works with 6. 5, no. 6 again works with 4. So I think we're just repeating ourselves if we go any further. So we're looking at the factors of C, but they have to add to B. B is negative 11, so let's be careful. Can we combine any of these two pairs, any pair, to get negative 11? And it looks like 3 and 8 has potential for 11, but to get negative 11, both would have to be negative. Do they still multiply to get this number 24? Yes, they do. So these are our factors. We can open up parentheses to get ready and insert our binomial. Insert the factor of negative 3 and the factor of negative 8. And we're done, except the question's asking for the zeros. So we're looking for what values would work for x to make the result equal to 0. That means this could be 0, or this could be 0. Either one works. Result here, x must be 3. Result here is x must be 8. So your answers are x equal 3 and x equal 8. Ooh, this is so cool. Here's another equation. So very similar to the stuff that we've been doing, but this number over here, by golly, it is not 0. So it's not enough to say that one of these things can be a certain number, one of these factors over here. So what I'm going to try is I'm going to try to expand this out and see what it tells me here. I've got x squared plus 17x is equal negative 60. Oh gosh. Well, now I have something that's x squared, a quadratic, right? Plus 17x is minus 60. It doesn't exactly look like this, but I think we could make it look like this because we do have the skills to work with something that looks like this. Let's go ahead and add 60 to both sides in hopes that we'll achieve what's in red over here. And oh my goodness, look at this. This is of the form x squared plus bx plus c, and it's equal to 0. So we'll be able to solve this equation pretty happily and pretty go-luckily. I said it. Now, we're looking for two factors of c, of course. Two factors of c. Well, let's list them. I'm going to have a long list here. 2 with 30. 3 with 20, 4 with 15, let's keep going over here, 5 with 12, 6 with 10, 7, no, 8, no, 9, no, 10 is back with 6. Good. So here we have it. And we're looking for two factors of 60 that combine for 17. Uh-oh. Uh-oh, SpaghettiOs. These have potential for 17, and these have potential for 17. But wait, the only way to get 17 here is to have a negative 3 and a positive 20. Will these multiply back for a positive 60? Ain't no way. So looking over here, you'd need a positive 5 and a positive 12 to get to this 17. And when you multiply, it gets you to a positive 60. So the real factors, please stand up, they are 5 and 12. Still equal to 0, and we're still solving an equation, so we're not done. For what value of x would this result in 0? Well, let's take it off to the side. X plus 5 equal to 0. If you solve this equation, you'll see that x is worth negative 5. If you solve this equation for 0, in the case that this factor were 0, you'd be looking at x equal negative 12. Hooray! There's our two answers for x. Please talk to me if you have any questions, comments, concerns, or confessions. And if you have any donations, just click the link below for my PayPal account. I'm just kidding, I don't have one. but that'd be cool.